Hi friends, in this session we will study about how to find inverse of a matrix by elementary operations of rows and columns. The concept behind this, if we multiply a number with its reciprocal, we get always 1. I explain you how we get it. Look at this. If we have to multiply 5 with its reciprocal, which is 1 by 5, we get 1. So this we start with this assumptions, this concept. Here, if a matrix is multiplied with its inverse, we get identity matrix. Then we try to convert this matrix A into I. We convert this matrix A through the elementary operations of rows or columns into identity matrix. And we have another concept. If a number is multiplied with 1, it always be same, because the 1 is the multiplicative identity of a number. So if you multiply 1 into 5, so it would be 5. It won't lose its identity 5. So 1 is the multiplicative identity. So here, if we multiply any inverse matrix with identity matrix, we get inverse matrix, the same matrix we will get over there. So the concept behind these elementary operations is, now we take an example of 2 by 2 matrix and we find the inverse of that. So I write down here a matrix A we have a matrix A 1 2 3 minus 5. This is a matrix we have. Now through this concept we start with this like this way. So I write here A inverse is equal to I. I put these values here. So we get here A is 1, 2, 3 minus 5. A inverse we have to find out. So we will write the same. Identity matrix of 2 by 2 is 1, 0, 0, 1. Okay. Now we have to convert this matrix A into identity matrix. Look at this. So this A matrix we have to convert in identity matrix. The first element should be 1. There is already 1 here, so we don't have to operate. We don't have to operate here anything. So we will make second term, this one 3. We have to make it 0. So what we have to do? It is already 1. In the second row, you see we have to make 3 equal to 0. So R2 tends to R2 minus 3 R1. From first row, if we multiply 3 and subtract in R2, just a moment, this is R2, this is not R3, we have R2 here. R2 tends to R2 minus 3 R1. So we do this operation here. Let us see what happens. 1 2 will remain same because there is no change in this first row. We have to change this. 3 multiply with 1, we get 3, and here we get, I write here 1 into 3 3, and there is already 3 in R2 minus 3 R1. So we get 3 minus 3 is equal to 0. So here we get 0, and here in second element 22 A22 we get here, we multiply 3 to R1, R2 is minus 5 we have here, and minus 3 into R1, R1 is 2, so we get here minus 5 minus 6, so we get minus 11, so it is minus 11 now. Okay, it is A inverse already there, and the same operation we have to do here. So if we multiply anything with 0, so R2 is already 0 here, R1 we are multiplying 3, so we get here minus 3, so it is minus 3 here, oh sorry, it is 1 already, sorry, 1 0, it is minus 3. Now here it is 1 minus 0 into 3, it is 1 already, there is no change here. Okay, so in this way we have got this 1 0. Now we have to make this 1 minus 11, we have to convert this into 1, because in any column first we have to make 1, then we have to convert other numbers to 0. So first we convert these into 1. So it is very simple process to convert any number into 1. So R2 tends to R2 divided by minus 11. So get here 1 2, there is no change here. If he is 0, divided by minus 11 is already 0, and minus 11 divided by minus 11 we get 1. This one we have. Now A inverse. The same process we have to do it right side. 1 0 minus 3 divided by minus 11, it is 3 over 11, so we have to put here 3 over 11. I just do one thing, just a moment, make a little bit. It is 1 0, and minus 3 over minus 11, it is 3 over 11 now, so we put here 3 over 11, and here 1 over minus 11, so it is minus 1 over 11. So we have got this. Now we have to make this 0. In identity matrix this element is 0. So for 0 we have to multiply these 2 in R2 and subtract R2, this new R2 from R1. So we write in this way, R1 tends to R1 minus 2R2. So here you see the operation. It is R1, first I write here, R1 tends to R1 minus 2R2. So here R1 is 1, 2, R2 is 0, so you get here 1 already, it would be 1, there is no change here. But here you see, it is R1 is 2, minus 2, and R2 is 1, so it is 0, you get here 0, and it will remain same. So we got here identity matrix, and the same change we have to make at right hand side here. So we see 1 0, so it is 1 minus 2 into 3 over 11. So we get here 1 minus 6 over 11. If we simplify this, we get here 5 over 11. So it is 5 over 11 now. Here it is 0 minus 2 into minus 1 over 11. So we get 0 plus 2 over 11. Here we get 2 over 11. It will remain same, 3 over 11 minus 1 over 11. So this we have got here A inverse. So we have got A inverse because we have converted this thing in the other form. Identity matrix into A inverse is equal to A inverse. So this applies here, identity matrix into A inverse is equal to A inverse. So we have got A inverse here. Five over 11, 2 over 11, 3 over 11 or minus 1 over 11. This is the A inverse. Or we could also write in this way, 1 over 11 we can take outside as a common. Or we can write here 5, 2, 3 minus 1. So this is the inverse of matrix A. So in this way we could find out the inverse of a matrix of 2 by 2.